examining the Apple TPM. So here's where I'm going to actually show you a little bit about what's going on in the Mac. It's not the grandest demo in the world, but what we did, let me see here. Oh, I'm not actually going to demo it yet, so give me a minute. They all use a TPM from Infineon, a company called Infineon. It's a version 1.1b chip. This is important because Vista and all the TPM capabilities of Vista, like BitLocker and things, want a 1.2 TPM chip. Anyone know if they actually have a system with a 1.2 chip in it? Bueller? I couldn't find one. We looked around and we found a lot with 1.1b, a lot. So there's a bit of an issue there. Just from a Vista migration path for everyone who has to care about that in the future, thankfully I probably don't. If you're going to do anything with a TPM on Vista, it's going to be hardware refresh, period. You're going to be putting in new motherboards or buying new systems if you want to use any TPM capabilities for Microsoft Vista. But I think that kind of goes in line anyway with what Microsoft's plan is, which is everyone has to have a bajillion gigs of memory and a couple terabytes of hard drive space in order to install it. So no offense to the Microsofties in the room, I apologize. Just had a, again, if you hadn't noticed, I'm on a Mac, so I kind of had to poke. Apple doesn't really have an interface exposed to allow you to poke the TPM, and it goes hand in hand with the rest of the way they've done stuff. For a long time, they didn't have capability to poke the Bluetooth stack. You know, if you were a coder and you wanted to do something with Bluetooth, you had two options. You could do what the Wi-Fi guys did and reverse engineer the protocol stack that they used and write your own hooks, or basically make a .h file so you could hook it. Or you fired up the wizard. So if you wanted to find a new device, you would actually just call this thing and it'd start a wizard and a little box would pop up. And then the wizard would return a device, which was a real pain in the butt. TPM had nothing. I found little hints of where it was. Again, I hadn't been able to find Maxis's patch, so I'm not crystal clear on where what kernel extensions were probing the TPM, and frankly, after 3 or 4 days of poking around in the guts of every kernel extension of my PowerBook, I gave up. Never fear though, we've got code to examine it anyway. So what we did is there's a Ubuntu live CD made by a group at mactellinux.org. First of all, booting under a new MacBook Pro is a very different ordeal. It uses EFI instead of BIOS. And EFI is a different kind of animal altogether. So the Ubuntu live CD is really strange because it doesn't look like a normal Linux live CD would. I tried to create a live CD for distribution here and actually ended up failing miserably and burned about 40 coasters in the process. What we ended up doing instead was releasing a tarball that you can blast onto a USB disk, which is a lot more convenient because then it's, say, persistent storage versus a live CD, and then just run around with your little USB disk that you can have and boot up whenever you want. So you can have your Linux booting on your MacBook Pro whenever you desire. So that's released. It's on that website, tpm.shmoo.com. It's a little big. It's like 680 megs or some nonsense. All the instructions are on the website to download it. But anyway, so we customized it. What we did was made all the TPM stuff work. I upgraded all the Ubuntu packages so there's no security vulnerabilities, no known security vulnerabilities in it. And then we made the TPM stuff work out the gate so everything comes online properly. It's all compiled, kernel modules work, all that good stuff. So anyway, the way that it works is that there's two different ways to interface with the TPM under Linux. You have the legacy libTPM from IBM. This is just standard issue library, right? It abstracts the calls down there. You can turn the thing on, turn the thing off. You can do whatever you need to do, and it accesses the TPM directly. The more kind of contemporary way of doing it is this utility called Trousers, trousers.sf.net, and they've got a daemon that runs that basically grabs the TPM device by the face, and the only way to communicate with the device from that point forward is a socket call to the TCSD daemon. So you get to do a little socket coding. So they have a pile of utils there that you can run and access the Infineon TPM. One thing of note, the default libTPM from IBM does not have a function to start the thing, so I had to write one. So if you download this image and you're playing around with it, there's no reason this shouldn't work on any TPM capable laptop. You should be able to download this thing and run it on anything. I had to write a startup thing, I'm going to show it off in a minute, that will actually make things work properly. So, all right, so it's real quick demo time. So just so you don't think I'm kidding around with you, let's do a uname-a. So here's this MacTel 2.6.16.1 Linux kernel. It's kind of far down at the bottom. I apologize. I can make noises while I do stuff because that always makes it better. There we go. Right now, if we look in here, this is the utils directory. There's like a TPM demo file. We try to run it, and fails with error 38, which what I eventually decoded was, the thing's not turned on, smart guy. So what we do instead is a TPM startup successful. Now we can do a demo. Look, magic happened. Hex flew by. I must know what I'm talking about. That's it. Oh, hey. All right. Yeah, thank you. I got one round of applause for screenfuls of hex. Is that what all the demos are supposed to look like anyway? More convoluted, the better. Honestly, this demo, you can read through the code, but it's basically, it's getting the thing going. It's resetting the chip just to make sure everything's clean. It gets the capabilities from the chip. There's, a breakdown of what the capabilities are. You can look them up. I didn't have time to write the magic decoder ring here so that this was all ASCII pretty. And at the end here, there's this big blob of goo, all Fs. These are PCR reads, trying to read the PCR registers that it has the authority to read. Right now, they're not initialized to anything, so they're all just a bunch of Fs. So Apple hasn't gone through and initialized this. I haven't done the take ownership thing yet, because I really don't want to break the PowerPC capability that this box has right now, especially coming into BlackHat. I didn't know what kind of capabilities I was going to need to have. When I get home, I'm actually then just going to try to screw around the TPM as much as I can until the PowerPC stuff breaks, which could be one command or it could be 50, at which point I'll have a little PayPal donation thing if you want to buy me a new MacBook. So at the end here is this big blob, and this is actually an important key. This is the public encryption key, and it's what uniquely identifies this host. This is the public key for that. It's not actually a full-blown cert. You can export it as, basically OpenSSL understood, PEM or something, but it's just a key blob. And so if you want to, ultimately, if you need to encrypt anything and shove it onto this, if you need to, whatever, shove data onto it or generate key material or import key material, this is the public key that you would use to do that. This uniquely identifies my system right now. Everyone has a unique one of these. So, if you're really interested, you could try to write this down and then figure out something to do with it, but I don't think it would do you any good. Anyway, so this is, it's funny because they call it a public key, but they still call it sensitive and shouldn't be released outside the system. And yet, here's this interface just to probe it and snarf all the data off of it. So, anyway, there's the long modulus. It's the pubic, which is really bad name. Anyway. So honestly, that's the whole demo, if you will. There are a lot of utilities here. You can load key, you can dump the key out, you can disable it, you can create it, you can do it. The kicker is, and what I'm going to cut to the chase on, because we're 10 minutes short on time. We've concentrated a lot on what the bad stuff is. I'll get to the stuff in a second. We've concentrated on what the bad stuff is. DRM, man, I'm gonna lose my privacy. Well, God, guys, let's look and see what Apple and Microsoft and all these people have done with the TPM. They at least have products out there that we can actually go and do useful things with. BitLocker is, like EFS on steroids for Vista. And then Apple's made it a core part of their product offering. What do we have in the open source community? Right, good. Glad we got that out of the way. This is a huge opportunity, right? And we need to get our thumb out of our butts with respect to being all worried about the privacy ramifications and all that stuff. Because trust me, there are people who are going to solve that. EFF is going to crawl all over people. And the ACLU and any other group that you can think of is going to be defending privacy and our ability to control our systems, whatever. And that's fantastic. They're good at it. Let them do it. As geeks, we're just smelly, long-haired guys who get in the way. Let's focus on making the world a more secure place. Let's get some tools written. Let's educate people about this. Let's actually try to make a difference. Let's give demos next year of, hey, here's cool TPM-enabled stuff that we've done. I've made EFS for Linux that uses the TPM for key storage. Ooh, neat. I got a firewall that stores all my IPsec keys in the TPM. Ooh, neat. Let's talk about that. Let's do stuff. Soapbox can get kicked off the stage now. Real quick, Trusted Network Connect. Rather than trying to solve the entire thing, doing like MLS from the get-go, they're taking some baby steps. Network access is a problem, pretty common. There's a NAC talk going on right now in some other room. So you've missed out, so I didn't tell you about that till the end. But the idea is, how do you control access to a network and your enterprise? Well, oftentimes devices don't strongly authenticate themselves. There's a password, something advanced as a password. TNC is basically 802.1x that has, basically the capability to tie into the TPM and use these keys that are stored internally to authenticate the device and the capabilities of the device to the rest of the enterprise. Pretty straightforward. Juniper already has it, and others already have solutions that are TNC compliant. Here's a really bad graphic I lifted from the website that I'm not even going to look at. Other capabilities, data at rest, obviously we've talked about BitLocker. This could be done on any platform though. Why doesn't Disk Utility in OS 10 make use of this for its encrypted file systems? I have no earthly idea, except it seems like Apple's not trying to use the TPM as a differentiator, trying to use it to protect their market share. Why doesn't Linux have any of this kind of capability? Because we're all too busy screaming about the privacy ramifications. Crypto API, that's the one thing that's nice, is you can go to the Trousers website and download a compiled version of OpenSSL that does use the TPM for all of its hoo-ha. So you don't have to rely on software. Pretty neat. And so in that case, it should be pretty trivial to compile your applications against it. I've compiled a few just to test them out, and they work fine. So I recommend going and playing with that if you can. Remote attestation. This is, again, when you can tell a remote system, hey, I'm this good, I'm that good. And I got a table on the next page that will explain it. Trusted boot. Follow the logic. You have the TPM. You have this controlled key, right? And secure cryptographic capability. Now I have a secure bootloader. And it verifies itself, the TPM verifies it and says, this is the bootloader I intended to load. Then the bootloader says, oh, I'm going to go load a signed kernel and verify that this is the signed kernel I intend to load. And then the signed kernel is going to load signed drivers, and signed drivers load signed applications. Note, signed does not equal secure. We had this battle with Microsoft, years ago when they started having all these signed code capabilities. Well, we know that, okay? I think we've internalized the issue that just because you sign something doesn't make it secure. However, if you've actually looked at the thing and you believe it to be secure and then you signed it, well, now we got a decent starting point. If I've got a bootloader that's been signed and then I use the TPM to verify it, well, I'm in a better state than if I'm just using some uncontrolled bootloader and hoping someone isn't booting from a floppy disk or a CD-ROM. Types of attestation, really quick. There's attestation by the TPM. Basically, it says, there's a TPM here, and I know a secret. Shh, don't tell anyone. Attestation to the platform. This basically says, proves that the endpoint can be trusted to report its integrity. It's not saying its integrity is good. It's not saying it hasn't been owned. It just says, I'm going to tell you the right answer. Now, the right answer may not be one you like, but I'm at least going to tell you the right answer. Attestation of the platform is basically saying, I am this good. I have this much integrity. Now, again, this is all software-based. The reporting ultimately becomes software-based. So, you have to make sure that this attestation reporting is, protected on its way out. But ultimately, this is saying, hey, I believe myself to be integral, or I've got some problem. And authentication of the platform, this is device authentication. This is the TNC type capability. So the bad. There's a lot of opportunity for loss of content control, failed hardware. We talked about a lot of these. Users need to deal with key material. Users can't send encrypted email to each other, right? So we got to make the key material handling an easy thing for them. And operating systems may get territorial. There's some concerns that Windows Genuine Advantage, for instance, would be basically say, oh, I won't upgrade your OS because you're running Firefox. Like that's the new conspiracy theory of the week.